today's lesson, section 4.5b. We'll talk about exponential and logarithmic equations. In the last one, we did the exponential part. This time we're going to do the logarithmic equations. So, guidelines are basically the same for logarithmic equations, just that they are for exponential, just you're talking about logs instead of exponential. So, we want to isolate the log term on one side. You might need to combine, so if there's multiple, like on either side or on the same side, you need to combine them so that they're just one single log. And then from there we can rewrite our equation into exponential form, and then or you kind of raise each side to a base or to a power kind of thing. Then we want to solve. Okay, so example 2, we want to solve the following equation. So for letter A, it's already a single log on the left side. So you have log of 25 minus x base 2 equals 3. So here, since this is a single log, I want to change it to exponential form. So that means that the 2 is kind of my base, and so it's going to go over and bump up the 3, which is my exponent, which leaves 25 minus x on this left side. So then 2 to the third power, and 2 to the third power is 8. Okay, so then from there I want to be able to simplify. There's different ways of going about this. I like to just add the x over and just get it to be positive. You can also multiply by -1 at the end, same thing. And then here you gotta subtract 8 to both sides, so x will equal 17. Okay. For this one, now also one thing to remember is that when you have logs, you gotta check to make sure that the number that you came up with, if you plug it back into the log you have to begin with, that both work, okay, so that you're not getting a negative solution, okay, because kind of like with the previous one where you kind of ended up with, like, I think it was example 1, letter C, we had -2 and a +3 at the end. The -2 didn't work because if it took ln of -2, it wasn't a thing, okay. So the same thing happens here, is that if I have a number like 17, I have to go back to my equation, and if I plugged it in, am I going to get a positive value which I could actually take the log of something? So if it's like makes it negative on the inside, then it's actually a no solution, okay? And sometimes that will happen, so you got to check to just make sure. You don't need to plug it in like physically and actually check it. Just take 17, think about it. So 25 minus 17, that's 8, so that's fine. Okay, so I don't really need to do anything. 17 is my answer. Okay, so just something, food for thought when you get down to your last answers, because we'll have those type of questions for like letter C and D for this video. So letter B, 4 plus 3 log of 2x equals 16. This is a common log. But still, I need to get the log by itself, so I want to subtract both sides by 4. So that gets me 3 log of 2x is equal to 12. And then there's a 3 in front, so I want to divide everything by 3. So log of 2x is equal to 4. Now because this is a 10, that's the base I'm going to move everything up to. Okay, so I'll change this to exponential form by saying 2x is equal to 10 to the 4th, okay, which is going to be 10,000. Okay, and then from there, now I want to divide everything by 2. So then x will equal 5,000. Okay, so then that would be my answer. Looking back, there was no like subtraction anyway, so 5,000 times 2 is 10,000, so that's a perfectly fine number for log to be taken to. Okay? Let's move on to the next slide. So letter C, you have log of x plus 2 plus log of x minus 1 equals 1. Okay, so here this is one of those where it's not one single log. You have two different log expressions that you need to combine before you can move on. So since it's addition that's putting them together, I need to use the product property. So the product property tells me to multiply the two things, the logs that are there. So I say log, so a single log, x plus 2 times x minus 1, which equals 1. Okay, now you can multiply them out if you want. At this point, you can wait. It doesn't really matter. I'm just going to wait until I change it to exponential form. So this is also common log. So the 10 moves over, bumps that up. So I get x plus 2 times x minus 1 is equal to 10 to the first, which is just 10. So now I want to multiply my stuff out because I want to be able to solve for x, and I can't do that when there's a 10 on the right side. So I need to make sure the 10 is over with all the other stuff on the left, so it's equal to 0. So I'm going to multiply through. So x times x is x squared. X times negative 1 is negative x. 2 times x is 2x. 2 times negative 2 is negative 2, and then equals 10. So now I want to subtract 2 to both sides. That makes that go away. And I also want to combine my like terms. So x squared plus x minus 12 is equal to 0. Okay. Then from there I want to factor. So I'm going to break it up into two binomials. So x and x, it's plus minus. So for plus minus, it'll be plus minus in your binomials. And now I want factors of 12 that subtract to get me positive 1. So that means 4 and 3 would be it. So 4 will be positive, 3 will be negative. And now I can separate them and solve for each individually, which are both one-step equations. So negative 4 to both sides and add 3 to both sides. So that gives me x equals negative 4 and x equals positive 3. So then now, here's where I was mentioning you want to check to make sure, especially when you have one answer that's negative. Okay, so go back. If you plugged in negative 4 into both of these, would you get any negative solutions in there? So log of a negative number, which you do for both actually. Negative 4 plus 2 is negative 2. So you can't do that log. And then log of negative 4 minus 1 is negative 5. That also doesn't work because it's negative. So going back down here, negative 4 is not an answer that works. Okay, so then let's check and look at 3. So 3 plus 2 is 5. That's okay. 3 minus 1 is 2. That's okay as well. So our only solution for this one will be x equals 3. Okay. So going to letter D. Now this one's a little bit more tricky when we're doing stuff. So I want to be able to still move everything to the same side. Okay. So if I move the 2 ln of x plus 2 to the other side, it gives me x squared minus 2 ln x plus 2 equals 0. Okay? Now, here, there are no tools in our toolbox to be able to figure out what solutions give us or make it equal to 0 for x. Okay? So what we have to go to is our graphing calculator. So if you go to your equation editor, you plug in x squared minus 2 ln of x plus 2 parentheses in graph, and where it crosses the x-axis are going to be your solutions. Now since it's squared, there should probably be 2 solutions here. Now if I go with a standard window from like negative 10 to 10 for both the x and y axis, I can see that my x-axis crosses. Now, one tool you can use is that, let's say in your equation editor, you also put in that y equals 0, because that's the x-axis. Okay? And have you regraph that. Okay? So now, using your calculate tool, you use intersect. You select your two curves at where you think that there's a solution, and it comes up with one of your solutions. So one solution, they say, is, let's say we round to nearest hundredth here, so negative 0.71 is one solution. Okay, and let's do the other one. So I want to do second calculate, go to number 5, intersect, and so go over to where you think they're going to intersect and select the first curve, and select the second curve. So then here the other intersection would be 1.60. Okay, let's go back and check and look at our equation compared to our answers. So negative 0.71, if I plugged it into the x in the ln, that would give me a positive solution, because negative 0.71 is less than 2, so that'd be like 1.29. Okay, so that's an okay answer, so that one passes the bill, and 1.6 is already positive, so that also works. So both of these are solutions. So sometimes the negative solutions work, sometimes they don't, but just make sure that you go back and check to make sure that they all work. Okay? Have fun.